you ever been at Osceola by
It's just
Store stuff.
So you're here to
It's pretty.
And then you can have different settings. You can, if you hit optimize, you'll find all these apps that are just using power right in the background. That saves a little bit of time, so that adds. That bought me 20.
Yeah. So we're in image space.
The fully charged.
Yeah, so I do letters.
I know, and I brought it up at
You hear the good news?
Got you.
Maybe it's going to run into
I can't remember if I actually paid for stuff or not. Sometimes I buy them if they're not that expensive. There's a free version.
I don't have any.
Right, CVHS.
But if I really like the app and it's good stuff, then I'll for bucks, I'll go ahead and buy it. They took the time to do it.
There's a save.
There you go.
It took me to a charge.
And how many of those just, some of those app things will start right back up as soon as you stay on it.
Occasionally I go and figure out.
Huh?
We're sitting there for 2 hours.
Yeah.
Before it's short, I can fire them out. Okay. Thank you. Hope this works.
Well, if that's done solved, then, the apps are right. I used to get these like emails that say, here are some of the best apps. Everything, I'll download them, find if they work, I keep them.
I had this default messages thing. I got rid of it because it suddenly became very slow when I started typing. After Android pushed an update,
Yeah.
my messenger just won't. So, yeah, text messenger. So then I went with something called Textra. It's been beautiful.
Really? Text? Never heard of that one. I just use the native one on the phone, and because Facebook, I'll check it with my phone, but it won't let you use messaging on Facebook without their app.
Yep. I don't blame you.
They force you to it. Don't let you do it. I mean, there are some good chat apps out there. I just downloaded HipChat because, our team is starting to do that.
Slack.
Slack works pretty good. I like Slack.
I think partly because almost everybody's on Slack, so that's part of the reason why we went.
When it works across, all your devices and everything. Very nice.
That's right, you should have done it. Yes, sir.
I'll put you in between.
You feel experimental?
25 minutes.
Unless somebody said.
No, there was nobody. Nope. Wow.
Yeah, you live in the internet. You don't even.
I haven't posted anything, I haven't updated LinkedIn in a year. Because you tell them, yeah. Listen, any startups in probation.
Well, I guess that's what I was trying to wonder. What point we were fighters of
Ready?
but they were back.
Let's go ahead and get started. We now come to session 4, which is about analyzing big data. If you remember, sessions earlier were about acquiring big data, both imagery and streaming. And then it was about maintaining and providing access to data. Now it's about analyzing data. And for session 4, my colleague Raj Singh will be our chairman. And you see the presentations. I don't know if you want to say anything about this, or you want to go directly?
Let's go directly in.
Checking to make sure I got nothing right now. Let's try it again. One guy on the line needs to ask a question at some point so that. Alright, we're getting closer. Voila. There we go.
Okay, so I'll just quickly introduce Dan Getman from Digital Globe, who's going to be talking about optimizing knowledge discovery from, or optimizing knowledge derivation from imagery. That's pretty loud. That sounds good.
Yeah, thanks. Yeah, I'm hesitant to use knowledge discovery because I used to work in Voodoo's team, so I know that's a Voodoo phrase. So if you guys don't know Voodoo, he's National Renewable Oak Ridge National Laboratory. So I'm working at Digital Globe. I have spent the last 10 years at the Department of Energy and several years before that at the Department of Defense, and so kind of been around on both sides of the fence from the big data perspective. But what I'm going to talk about today are, I guess what I should say is, what I'd like to discuss today is what we're thinking about in dealing with some of the issues that we have with big data. Because I feel like there's so many things that have been brought up and so many solutions that have been proposed and problems that have been brought up. And I think the original intent of this, and we're trying to sort of reach that, is just to have a conversation about it, to really think about where certain things work and where certain things don't, and where they're going. And so that's really what I'd like to kind of instigate in this presentation. So if anybody feels inspired and wants to jump up, I'm sure Peter will run the microphone back to them. So we obviously deal with big data. I forget who said it, but I thought we were the early big data guys, right? So we've been dealing with big data for a long time. And 70 petabytes of satellite imagery is actually outdated. I think it's getting closer to 90 petabytes that we have available right now. We get about these images, these big strips that you guys have probably dealt with from various providers or from us. They're like 30 gigabytes each. And we cover the globe annually with several billion-dollar satellites, right? And so when I think about our data, I think of it as being big data, but I also think of it as being really heavy data, really challenging data to deal with. It's not light and easy with like Twitter is, for example, and Twitter's got much more data than we do. But I think the data are just different to deal with because they're such small individual things. And so we're dealing with sort of two ends of that spectrum. But we also deal with the other end of that spectrum too, because most of what we're doing with the imagery I mean, the reason we collect it is to do analysis on it, right? So we do analysis internally, we provide it to people that do analysis, and we're pulling lots of things out of it, the buildings, the planes, and the cars, and the change, right? And all of that winds up being light big data. And so we're dealing with that as well, you know, both in the analysis that we're doing and in the things that we're pulling out of the data and the clients that we work with. And so what this means is that we need to coordinate between sort of this heavy, slow data and this light, fast big data, because at the end of the day, what we really want to get is knowledge, right? It's one thing to say, I can tell you how many airplanes are at an airport. It's another thing to say, I can tell you how many boats are at a port, and I can do that every single day. But it's something else entirely to be able to say, there's something happening at this place, right? There is a behavioral change at this airport, or there is a behavioral change at this port. And that's really what we're trying to get at, is how do we actually integrate what we're doing with, you know, sort of this revolution in big data and data science, so that we can really support that kind of knowledge discovery from the data that we're collecting over the globe. So we deal with lots of different use cases. Am I blowing everyone's ears out? I could hold it down here. You guys did okay? All right. So we get lots of different use cases for these data. We have people who say, I need the raw information off the satellite. Spectral integrity matters. I'm doing complex classifications. And we have the other end of the spectrum where they couldn't possibly care less about that, and what they want is a 0 to 255 RGB JPEG. And they're just doing their change detection with that. We have the same problem with the size, where people want the whole strip, or they only want a little bitty piece of the strip. And they, you know, neither of those ends really understand the other. Like, why would I have to get a whole 30 gigabyte strip to get a few K of the AOI of interest? And we have people who want to have the image forever and cuddle it and put it up on their wall in a frame, and people who don't want to see the image at all. They only care about the information that's in it. So we deal with all of these use cases at the same time, which makes all of the paradigms that we're talking about for storage and analysis and things like that, all of those are relevant in our use cases. And so that's why we're talking about how we apply some of these methods to Digital Globe. They all have the same thing in common, though, which is they want to go from what the satellite's doing to knowledge. They want to understand something. And that's really, at the end of the day, what everybody who's pulling this imagery down and everyone who's accessing our data, including us, is doing. And so we need to make that fast and flexible, and we need to integrate it with modern data science. So we are thinking about how to do this, and we're experimenting. We have a few pathways for doing this that we've laid out that are really working well for us. But we're looking across the spectrum of how people are accessing data, and we're seeing some paradigms, right? So this is the one that we've been talking a lot about, where the data provider, this one at the top, is you're just getting an image. Here's your image. Go do something with it, right? You download it, you put it on your local hardware, and you create knowledge with it, right? Another pathway is to create these big cloud stores where it's just an S3 bucket or some other bucket in the sky, and all the data is in there, and you can open up the README file, and you can see where the data is, and you can go and download it, or you can move it over to your scalable compute and do something with it. And the last is, and I have more trouble understanding this one, but I think it's because I have a background in image science, is when people just want the tiles. They just want to hit the WMS and get all the tiles and then do change detection with these already post-processed JPEGs or PNGs or something like that, right? And so we see all of these paradigms being successful. We see really good analysis and really good science happening in all of these sort of cylinders of excellence, if you will, as opposed to silos. And so what we're trying to do is we're trying to figure out a really good, reliable way of doing sort of both ends of the spectrum as far as image access is concerned, right? So in the first one, we're looking at a way in which people can analyze these big strips all at once in a compartmentalized way that allows us to provide access to the data so that analysis can happen without actually having to give someone the data, or without someone actually having to buy it or download it, right? And so we've got a cloud-based image processing framework that we call the Geospatial Big Data Platform to do that. And I'll talk a little bit about the architecture of that, and hopefully we can open up the discussion about, you know, some of these other ideas and how they might fit in an architecture like this. Excuse me, I had too many jalapenos on the sandwich, I think. So the second paradigm is this idea. You guys, am I still on? Yeah. The second idea is this second paradigm is this idea of tiles. That people obviously want to access tiles. They obviously want to get subsets of imagery reliably and easily, right? And that's why they're hitting these WMS servers to get the tiles. And so we're looking at how can we actually produce tiles and provide access to it in the same way, but actually give full resolution, full spectral fidelity data, but on demand right where you want it. And then any processing that needs to happen to it would happen when you request it. So I'll talk a little bit about that. So first I'll start with the whole image. If you have to eat the whole elephant. So this idea of, you do land use land cover, or you're searching for something, or you're looking for change, development, things like that. A lot of times you actually need these whole strips to do that work. And so we're very much focused on providing a framework that allows you to do analysis on a whole strip. The way that it works is we have our own sort of set aside in Amazon where we've got our images up on the cloud. We have compute sort of set aside, and we have our own algorithms already set up, right? So if you search the catalog, which is searching essentially the imagery that's available there, and you say, for this image, I want to run A, B, C, and D, and then spit out the answer. Whether it's an image, like a land use land cover, or whether it's data, or not data, but tabular data, or feature data, or what have you. And so the analyst never really touches the image. What they do is they either choose